LegalizeFreedom.com. Why are we here? Where do we come from? Where are we going? From the nature of reality to the future of humanity. Beyond politics, poverty and war. LegalizeFreedom.com.
Greetings and welcome once again to LegalizeFreedom.com. I'm your host Greg Moffat, and my guest today is Fred Kuttner, who joins us to discuss his book, Quantum Enigma, Physics Encounters Consciousness. In trying to understand the atom, physicists built quantum mechanics, the most successful theory in science. But they found, to their embarrassment, that with their theory, physics encounters consciousness, a mysterious phenomenon that science cannot explain and cannot ignore. Attempts to interpret the meaning and implications of all this are often controversial, but every interpretation of quantum physics involves consciousness. And the connection of consciousness with the universe suggested by some leading quantum cosmologists is mind-blowing. There exists a boundary beyond which the expertise of physicists is no longer the only sure guide. In the few decades since experiments established the existence of quantum entanglement, interest in the foundations and the mysteries of quantum mechanics has accelerated. In recent years, physicists, philosophers, computer engineers and even biologists have expanded our realization of the significance of quantum phenomena. Quantum theory tells us that an object can be in two places at the same time, that its existence becomes real only when observed, and that the observation of an object can instantaneously influence another distant object even if no physical force connects the two. Quantum theory thus denies the existence of a physically real world, independent of its observation. Hello and welcome, Fred, and thank you so much for joining us today on LegalizeFreedom.com.
Well, thank you, Greg.
Fred, today we're going to talk about a book that you co-authored a few years ago, and it's entitled Quantum Enigma, Physics Encounters Consciousness. Before we dive into that, perhaps you could just tell listeners a little bit about your background and how you came to write the book in the first place.
Well, I was a physics major originally and went on to get a PhD in physics, left physics for a while to go into industry. And when I decided to go back into the university, I struck up a renewed collaboration with an old friend of mine, Bruce Rosenblum. And in the intervening years, he'd gotten very interested in the foundations of quantum mechanics and what quantum mechanics means. And that was something I'd always been kind of marginally interested in. But with Bruce's encouragement, I dove into it in more depth. Bruce had started teaching a few years before a course for non-science majors called the Quantum Enigma. And after a few years, I took over that course and taught it for a while. And then he and I started talking about writing a book. Bruce had written lecture notes for the course, and at first we thought about turning that into a book, but then we decided that we'd like an even wider audience, so we decided to write a book aimed at people who didn't know any physics at all. And after a few years of struggling, we came out with Quantum Enigma.
Well, regulars on here are going to have at least some basic grasp of some of the tenets of quantum physics, what it's telling us. But just for people who are perhaps rather new to this, perhaps you could just briefly set out the basics, basically, of what has fundamentally been learned in the last sort of 80 years or so. Maybe by way of an example, I don't know, wave particle duality or the box experiment, whatever you think's appropriate.
Okay. Well, before quantum mechanics, physics we could regard as having two major branches. There was the branch that dealt with the motion of particles. That would be mostly Newton's laws, and that predicts the motions of planets and rockets and things like that. Then on the other side, there was the physics that dealt with waves, of course, ocean waves, sound waves, but most importantly, light waves, when it was discovered around the turn of the 18th to 19th century that light acted like a wave. And then with the triumph of James Maxwell, who wrote some equations that tied together all of electricity and magnetism and showed that light was a wave of electricity and magnetism, that opened up this whole area of wave physics. So around 1900, there was these two different areas, and things seemed to be either a particle or a wave. Starting with Max Planck and then Albert Einstein, it became clear that first light, and then it seemed all matter, particularly at the atomic level, appeared to have both of those properties. And it depended upon what experiment you picked. You could demonstrate one property or the other. And the connection between those two really has never been satisfactorily explained. We kind of have, if you wish, in some ways, we have a dualistic physics. Whenever you do an experiment, you can either demonstrate that, first subatomic particles and now things as big as buckyballs and even larger, can be demonstrated to either have a wave-like nature, that is, they're spread out all throughout space, or they have a particle-like nature, that is, they're localized in one position. And it seems that it depends upon your free choice of experiment which you demonstrate. So the question arises, which we put in our book, well, what was it, in a sense, what was it doing before you looked? And the answer is, we don't really know. Some physicists say, well, it doesn't make any difference. We can predict the result of experiments, and that's all that physics is supposed to do. Whereas other people say, well, we'd really like to know something about the nature of reality. And if physics doesn't tell us about the nature of reality, do we have to go back to leaving that to the philosophers? That's kind of where we are today.
Yeah, I think that's one of the main threads running throughout your book is setting out just that, this sort of tension between conventional scientists and physicists in particular, who want to just concentrate on the practical purposes and, well, this is what actually happens here. You know, what's happening at the micro level, does that directly correspond to what's happening at the macro level? Does it matter? Whereas particularly lay people, such as myself, we get seized and utterly fascinated by potential implications and meanings. And of course, science doesn't really do meaning, not in a sort of human sense.
Right. Yeah, that's probably the major tension. And it's a minority of people who care about, the implications of it. But among those minority, we have to include some of the, brightest minds in 20th century physics and, of course, now 21st century physics. So, we were accused in one paper that was written, we were accused of doing metaphysics. And my answer to that is, well, what's wrong with that? If by metaphysics we mean including the implications of physics, to my mind at least, that's a perfectly legitimate inquiry.
Well, yeah, because I think that we've got, particularly since the time of Newton and Darwin, we take them as sort of a package in terms of the effect they've had on our attitudes to the natural world. We've gone down. Obviously, there's been a lot of things that the science has brought us in terms of technology and developments, and we've learned a lot about the natural world since we were able to examine it, microscopically, for example. All sorts of things you can do in a lab and have been done. But for me, and again, this is something that lay people, I think, are more likely to go to, that there's a bit of a blind alley at times with just dissecting things and sticking them under a microscope and trying to then understand what this means and where we fit into all of it.
Absolutely. Somebody once said, and the odd thing is that scientists are usually, at least in the beginning, motivated by that kind of desire for a deeper understanding. Somebody once said, science is a wonderful field for discovering the answer to all sorts of questions, except for the questions you went into science to find out.
One of the sort of headline eye-catching statements in the book, and this comes up again and again because it underlies it, is this notion that a common sense physical reality is impossible. And for most people, that's, well, how do they grasp that? But really, gets back again to the difference between looking at the quantum world with scientific instruments, seeing the oddities, the bizarreness, the paradoxes, and then saying, well, okay, that's interesting, but it doesn't relate to the world that you and I are occupying now. For example, Newtonian laws work on large objects, again, like you and me, trees, rocks, all the rest of it. At the quantum level, there are different rules, but relating to what I just said, but surely the macro objects are made from micro particles, so there has to be a relationship there. That's certainly, again, what a non-scientist would conclude.
Oh, absolutely. I mean, that's a great observation, and that has been kind of the central conundrum of quantum mechanics since the beginning. How do you get the classical world out of the quantum world? And in some sense, you can do it, again, using the expression that, was a favorite expression of John Bell, FAPP, for all practical purposes. For all practical purposes, you can demonstrate that the classical world comes out of the quantum world, but it doesn't quite work if you take quantum mechanics seriously, because in quantum mechanics, basically what you're saying is that an object is in a certain state, and depending upon the kind of observation you make, you change that state. And basically, you change the state to be consistent with the results of your observation. But there's no way for that to happen in quantum mechanics. So, in other words, we call that the name, the kind of technical name that it got called was the collapse of the wave function. In a sense, the simplest way to think of it is in quantum mechanics, a particle typically is spread out over a region of space. But when you look, well, obviously you find something in one place. We never see something in two places at once, at least not if we're sober. So, how does it go from being in all those places to being in just one place? And that's something we don't have an answer to. The FAPP answer is, well, it doesn't matter how it does it. We just know that quantum mechanics predicts a certain statistical distribution of results. In other words, you'll find it 50% of the time here and 13% of the time there and 17% of the time somewhere else, and et cetera, and that's all. Now, people who want to take that a little more, say, well, that's not good enough. What happens? Try to come up with a way that you can transition from this being everywhere or to being somewhere. And that has led to such strange ideas as many worlds, which says, well, actually, it's still in all those places. There's just a whole lot of different yous, or in some cases, a whole lot of one you, but a whole lot of different states of your mind, which correspond to all those different possible positions, which is a interesting idea, but nobody's ever actually been able to nail that one down problematically either. It's an idea that sounds very good, but when you try to get the details, you get nowhere. But some people like it. I find it kind of bizarre, but
well, that goes with the territory, really, isn't it? Bizarre.
Well, yeah, it's possible, but I think that's sort of bizarre to the bizarre power.
Well, that's sort of for all practical purposes. It just made me think of something like, taking all the great works of literature that exist and using them only for propping open doors or propping up rickety tables. It's kind of it's not getting to the heart of the matter.
Did you ever read C.P. Snow's The Two Culture?
No, actually.
Very interesting. You know who C.P. Snow? It's a Brit. You should know.
Well, you're forcing me to reveal my ignorance now, so I might cut this.
That's okay. That's okay. You're younger than I am. He was interesting. He was a writer. I can't remember. He wrote novels. I can't remember any of the novels he wrote. But he started off as a chemist and turned to literature. And he wrote a book about the difference between the two cultures. And one of the things he remembered talking to a scientist about books, and the scientist says, well, to my mind, books are tools. So C.P. Snow says to his mind that brought an image of the scientist using the book to dig in his garden.
You talked there about having ideas that are sort of like not provable, and it's just you don't get anywhere with them in a practical sense. But I mean, I've read even about certain particles being actually theoretical, things that I'd read some books that I sort of felt I'd been led to believe, maybe again through just a layman's perspective. Okay, so they've observed that, they've measured one of those, that they understand the properties of this, and then I find out that, oh, actually, well, those particles don't necessarily exist at the moment. They're theoretical because they've been devised to fit with the observables.
That's an interesting question. What does it mean for something to be real? That's the problem with quantum mechanics. It calls those into question. If you invent something, I think, are you talking about the Higgs, for example?
Well, yes. That was probably the perfect example, really, because I read that had been experimentally confirmed now as existing. But I didn't hear, even though we heard a lot about the Hadron Collider on the news,
right.
The mainstream media here, certainly for popular consumption, seems to have missed out the fact that this particle is now confirmed as real. So I don't actually know where we are with that.
I think the consensus is it probably is.
It's reassuring.
Well, do you know anything for sure?
Oh, no, and that's the sort of question I love to ponder. But I suspect that if you're working in a lab somewhere at a university, being funded by some corporation or other, sort of saying things like, well, what is real? Do you know anything? And, they kind of get a slap on the wrist for that.
Right. By the way, about many worlds, when I said didn't go anywhere, I didn't even mean that it wasn't practical. I meant you couldn't even nobody's been able to come up with kind of a well-developed theory for it. It's still all quite vague. That was what I meant about that. My idea of couldn't go anywhere with it is a theorist's idea of it. Still very far removed from what anybody would consider practical. But the Higgs, probably not going to be practical, although Herman Wouk, an American writer, wrote a novel about supposedly a Higgs bomb, although it was just you couldn't really do a bomb with it. It was just something a congressman thought of. But to me, one of the most interesting things is quantum mechanics calls into question what is reality. And of course, an issue that's been raised by philosophers for thousands and thousands of years and, well embedded into religions like Buddhism. To me, having studied Buddhism, I can't consider myself a Buddhist practitioner, but having studied it, quantum mechanics in some ways always sounds like Buddhism. Now, I don't know what that means. I mean, I don't know. I don't think that means that quantum mechanics has proven Buddhism is true, which was something that an acquaintance of mine, Friedrich Capra, basically argued back in the 1970s. But I don't know what that means. But it's certainly strange. Quantum mechanics, leads us to think all kinds of strange things that quote, sober scientists probably wouldn't have thought if it weren't for that. I mean, the problem is quantum mechanics works so bloody well. I mean, it's the best theory we've ever had to explain anything. I mean, you can go, at least according to, it's the way scientists think. I mean, we can calculate that the certain property, technically called the anomaly in the spin, magnetic moment spin connection in an electron -2, we can calculate to within 12 significant figures and go in the lab and measure it almost exactly to that. So, you kind of have, at least from a scientific point of view, you have to say, well, this theory's got to be right. At least certainly as far as we know, and we've gone pretty far with it. But it's so bloody strange, it can't. Somebody once said that Newtonian physics explain the world very well. It just got the details all wrong. Quantum mechanics gets all the details right, but it can't explain the world.
Quite. Well, this indicates then that there's still a lot that we're missing. And you mentioned Buddhism, and it kind of reminds me that with classical physics, classical science, I say from sort of Newton onwards, there have been a lot of these sort of advances in understanding that I mentioned earlier. But there also seems to be a bit of a sort of a de-integration. If you think about the early sort of gentleman scientists, a lot of them were church ministers. A lot of the early universities were funded by the church. Not saying that was good or bad, but just that seems to be the roots of it. But going back hundreds or even thousands of years, in previous cultures now sort of long lost to us, again, some of their worldviews, we can look now and say, well, they had part of the picture and not this part of it, and they thought that the sun went around the earth, etc., etc. but it seemed to be a more integrated, there seemed to be something that they seemed to understand about the universe and about our place in it and about the relationship between mind and matter, or even body and spirit, if I can use that word, that modern science kind of like just completely denies, even though I think we're facing a convergence once again of disciplines being almost forced together that were prized apart.
Well, but you said a lot. I'll address some of it. I'll try. It's certainly true that many earlier civilizations that we know have had a more integrated worldview. I think in the West, the last attempt at that was by Thomas Aquinas. The last great attempt at synthesizing everything. He synthesized Aristotelian philosophy and science with, the viewpoint of the Catholic Church. Of course, he'd followed on Maimonides, who'd followed on the Arab philosophers. But, it certainly has fallen apart since. And the problem was that so much of what the earlier peoples believed, I think the problem was it was all tied together. In other words, you kind of had to buy it all at once. And as you tend to, you tend to buy what a society tells you all at once. And since science seemed to attack a lot of it, science was successful in curing diseases that people attributed to demons or the work of God or something before, and able to make sure your crops got out even when it didn't rain. Things like that, where before people would have prayed. I think, as we say, maybe if not in our book, in our notes, when your car breaks down, you may pray, but mostly you're going to take it to a mechanic to get it fixed. And, that's kind of our attitude now. In every practical area of our life, we expect to have a, kind of a logical explanation, and we no longer invoke, the deity, except maybe in extremis. But most of us, at least, still plan on going to the doctor if we're sick. And, if we pray, it's, kind of an adjunct. And I think that more, the success of science in the practical areas of life, more than anything else, has broken down that connection because, well, my goodness, if it works so well, what do we need anything else?
Sort of slightly beyond the remit of your book, but there's certainly some, I was having conversation recently with some humanists who also overlapped with, as some of them were what they call themselves skeptics, as in Skeptic Society.
Sure.
They were debunking sort of psychic phenomena, but they used the easiest examples. The sort of faith healer type who turns out to be working with an earpiece turns out to be a complete charlatan.
Sure.
Psychics who are sort of, claiming to be able to solve crimes, and then the police actually go out there and do the work, and it turns out to be a complete hokum, right. Completely different cause. But again, I'm no expert in this area, but some of the rigorous scientific experimentation, has been duplicated with certain psychic phenomena, for example, like remote viewing, does suggest that, a mind-matter interaction that perhaps quantum physics will perhaps shed some light on someday.
Yeah, our feeling is that if such things are proven true, and as we say, there has not yet been evidence that will convince the skeptics. My feeling is if psychic phenomena, what people traditionally call psychic phenomena exists, and honestly, I don't know, they're weak. Sure, they seem repeatable, but you got to do a lot of statistics to kind of show it. And, sometimes it works, sometimes it doesn't. Works better with meditators than with non-meditators, all that kind of stuff. And the evidence is not enough to convince the skeptics. And, that's kind of what we need. And we're not there yet. It's still a case that the believers believe the evidence and the non-believers don't believe the evidence. That's got to be shifted before it becomes something that, you can get a grant from the NSF to investigate it. Of course, you could still, for a while, the Navy funded some of that stuff. My co-author, Bruce, actually was asked to review some work that the Navy had paid for about trying to communicate with submarines through remote viewing. I think he didn't do it, but he didn't do the review, but he was certainly asked to do it. But quantum, if that's proven to be, beyond a doubt, beyond a reasonable doubt, then I think, yeah, you're looking at quantum mechanics certainly for part of understanding of how that works. My feeling, about the whole mind-body relationship, or I don't know about the mind-body relationship, but, the mind, I just got a issue of Technology Review, MIT's alumni magazine, and it's called Hacking the Soul, and it's all about this stuff about, curing schizophrenia and, understanding what's going on when people feel things and so on. And that's all very, very interesting, although, probably overhyped, certainly overhyped in the popular press about, its application in psychology. But, science, according to Erwin Schrödinger, and I think he's right, started off with the Greeks by saying we are going to exclude the observer from science. We are going to do objective science. Well, guess what? If you exclude the observer from the very beginning, you don't find an observer. On the other hand, what's closer to me? What do I know more than my consciousness? If you're a solipsist, you can argue I don't know anything but my own consciousness. So to me, it's such a primal fact of our existence. You can't possibly ignore it and make any sense out of the world. Now, we have understood, as you pointed out, an incredible amount, but leaving consciousness out of it seems to me, in some sense, missing the whole point. Or at least at some level, if you're trying to say, well, my aim is to understand the nature of reality, without at least acknowledging the existence of consciousness, then you can't possibly understand, quote, the nature of reality, unquote.
Well, then you get into the issue of subjectivity, because and what then counts as evidence, what can be measured against what can only be sort of experienced, and then even then not by everyone at any given time. Because I think this isn't meant to be like a criticism, it's just a sort of an observation that quite a lot of science seems to deny subjective experience. You might have synchronicity happen in your life, unexplained coincidences that might happen in your dreams. There's all sorts of subjective human experience we can have that just not only doesn't fit in with a sort of cold scientific paradigm, but it seems that it's beyond our understanding as things stand.
Well, it's beyond our scientific understanding. There's certainly a lot of understanding of it. I mean, clinical psychologists, psychoanalysts, novelists certainly have brought a lot of our understanding of those kind of things. But that's, it's questions, do you want to call it science or not? And part of the problem is in our societies, science is that, you say it's scientific, it has this imprimatur, that somehow or other it's good, science good, everything else bad, which is, seems to me kind of ridiculous. A friend of mine used to say, well, science isn't everything and science isn't nothing. Science is one way of grasping hold of our experience. I don't believe it's the only way. And, like most successful enterprises, science tends to, in its, or scientists in their, more expansive moments tend to think if it's not science, it isn't worthwhile. Just like, if you're a fundamentalist religionist, if it doesn't accord with Christianity, Judaism, Hinduism, or Islam, it's not worthwhile. If you're a free market, purist, if it doesn't come out of the free market, if it comes out of government, it must be bad. All our endeavors, we tend to think that they're everything. Science isn't everything.
I read it, and it's just as a little aside, I read an interesting short little speculative piece a couple of years ago about the search for the Higgs boson, and this person was coming at it from the perspective that the observer and something coming into reality said that these guys are going to look hard enough, they're going to create the particle.
Well, in some sense, we did create it. I mean, there are, you can say that Higgs, according to our theories, Higgs exists in virtuality all the time, and they're what make possible all kinds of things that happen. But to actually produce one that you can handle requires the energies that only exist now in the LHC, or some first fraction of a second in the universe. Bruce and I were talking a lot about that. Did any of these things exist before scientists thought of them? And we were actually thinking about writing a book about that. But unfortunately, I don't know, Bruce died back in February. He was 87, not in good health. And, I don't know, we collaborated for about 20 years. I'm not sure I know how to write a book or write papers without him. So I don't know where that goes, but we certainly entertain that same kind of idea that you mentioned.
I'm so sorry to hear of his passing. I wasn't aware of that. But here's another, again, total layman's question. Just try and bear with me on this. We talked earlier about quantum phenomena, sort of subatomic particles and their reality or otherwise, and some of the stuff being theoretical. Subatomic particles, is there anything that with the tiniest pair of tweezers in the world that we can pick up and turn around and look under it and look on top of it, and what's it made of?
The problem is that it depends upon what you mean by looking.
Because you do say in the book, you raise the issue of what even is observation, never mind an observer.
Right. I mean, and again, we've talked a lot about that. Bruce and I talked a lot about that. Some of it didn't get in the book. Heisenberg said electrons aren't things; they're only theories. But on the other hand, and on the other hand, what about a nebula or a quasar or something that you can only see in a telescope? Does that make it only a theory because you can only see it in a telescope? That we have extended the reach of our observations so far, that it's so far removed from, our current reality. I mean, we know most of the time, if we're awake, if we're sober, we know most of the time what we mean when we say something's real. But, as we know, that's something that's problematic, Some might have some memories, and I am not sure, did that really happen, or was that something that happened to me in a dream? The further you get removed from the here and now in front of my face, the less sure I am of reality. I mean, it's almost in a way, it just comes to my mind that, maybe things aren't real or not real. Maybe it's a continuum, what was that book, the kids' book? I don't know if you read it in England, about the bunny that became real because it was loved. maybe everything in the world is like that,
Yes, sort of shades of a butterfly effect or something like that. But
yeah,
in terms of this continuum or spectrum, then what constitutes reality? Obviously, we get the feeling you mentioned about nebula and stuff like that. I mean, we're pretty content that the moon is there when we don't look at it. It's one of the little examples you use in the book.
Right, that was Einstein. Einstein's example.
When do the microworld rules begin to... At what point can we no longer observe them? For example, you made the point, and this is something that's most interesting to me, is that the Microworld Observations are gradually getting a little bit more macro. I think you said even that perhaps something as large, he says in air quotes, as a virus could display quantum properties. So where are we with that work?
It's gone in different directions. I mean, I'm not sure, though. And again, it all depends upon what you mean by an object. The problem is, again, that once you start getting into the microworld, what is an object, and gets a little fuzzy. But certainly I know that large molecules have been, and I think even, I can't remember, but I remember reading some very large molecule, even bigger than a buckyball, was placed in a situation where you can say it was in two places at once. But now remember, we maybe by our nature, by evolution, don't see something that we identify as an object in two places at once. We have to infer that by doing what we call an interference experiment. So it's kind of not a very long chain of inference, but it's still at least one or two steps of inference to say something was in two places at once, even though we never see it in two places at once. On that scale, we have actually built things that you can see with your naked eye, that we can then place in two states at the same time, but we cannot see it that way. We can just infer it was that way from some other measurements that we do. So in some sense, we can place macroscopic objects in two places at once. I'll use places with a quote, but human beings aren't constituted to see that. So it has to be always sort of an indirect observation.
Well, Aldous Huxley said something along the lines of that, the human brain should be able to perceive everything that's ever happened ever in the universe instantaneously, but our...
But he took psychedelic drugs. So.
But that our senses, our brain limits our perceptions in order so that we're not overwhelmed. So where I'm going...
Towards the perception, yeah.
So where I'm going with this is simply that the faculties we're using to observe as human beings, as living, breathing creatures, may be, we see how much we're able to extend that through the use of, scientific apparatus. So it may be something there. It may be just limitations of our perceptive abilities that would, if they were somehow altered, that not necessarily with the use of psychedelic drugs either, but that there might be a lot more open to us.
Oh yeah, matter of fact, we even we've talked about how could you make creatures that were different that would regard it as usual to see things in two places at once, and it's not inconceivable that that's possible. Okay, there's nothing in quantum mechanics that says you couldn't see things in two places at once. Then you bring in the Heisenberg uncertainty principle, which says then that. There'd be other limitations. There seem to be built into nature some limitations, but you can change the kind of limitations that you have. Whether you could perceive everything at once, I don't know. What that means by everything. I mean, I'm a finite creature, something that becomes more and more more and more aware of all the time as I get older, and as friends of mine die off, unfortunately, my limitations in time become more and more apparent to me, and that's the nature of being a human being. We are finite creatures. We will never be able to even conceive beyond a certain limited range of what's going on in the universe. And certainly nobody's ever thought seriously about it, ever thinks that we ever could. I mean, the religions all say God is basically beyond human understanding. And, I would say the totality of the universe is. So, we just have to accept the fact that we are limited human beings, and maybe quantum mechanics, we've reached one of those edges. I suspect there are places that science can't go, but the interesting thing is we don't know where those edges are. They're not hard and fast. The edges, if anything, are fuzzy, and if we try really, really hard, we seem to get a little further. But there's probably, I'm sure there are limits to what people will ever be able to understand.
One of the reasons that science, I suppose, sets certain things aside. As you say, science isn't everything, but it's also nothing, and there's certain things that are sort of beyond its remit. But there does seem to be still resistance to the idea that there is the truly ineffable, and that there are certain things that for human beings are unknowable. The perceptions certainly in the early days of modern science was that, who was it in the Victorian era said that basically the facts were all in, just remained to tweak a few details. The perception for a long time was that we were, with increasing pace, reaching an explanation for more or less everything, and that kind of unraveled in the 20th century.
Yeah, that's one of the most fascinating things is how that did unravel. And of course, that goes down to something I've been thinking a lot about. What do you mean by an explanation anyway? I mean, explanation, some people are satisfied, with it's God's will. That's an explanation. For some people are perfectly content with that. Other people are not content with that as an explanation. To my mind, almost what is an explanation is almost it's almost a purely psychological idea. What counts for you as an explanation? And then, sort of as a societal thing, we've decided that a certain kind of explanation is sufficient for science. And we say, okay, we have explained that. But other people aren't satisfied with that. Again, that's the big at the center of the quantum enigma is that issue right now. Some people say, well, the quantum mechanics we have is sufficient as an explanation for everything, and other people say, well, quantum mechanics itself requires explanation. I don't know if you'll ever solve that. I'm not sure you do. Again, it's a really a social. I think it's very much a social thing. What counts in our culture, particularly the scientific culture? What do we accept as an explanation? And I think the silly thing that science do is say, well, if we can't explain it, it doesn't exist. I mean, that's just silly.
Yeah, I think science had perhaps done itself a bit of a disservice by being so dogmatic when dealing with the general public and dismissing things like that. I think there's probably more of a middle ground that could be taken. Because you quite often find, as your book is kind of evidence, you quite often find that scientists, behind the scenes, as it were, do talk about these things.
But but typically it's a minority. And we got a lot of flack where we taught at UC Santa Cruz. We got a lot of flack for saying we were encouraging people to believe all kinds of strange things. In other words, the idea was that if you teach people that quantum mechanics is strange, they're going to believe in UFOs. Okay, I mean, I think in an overly simplistic way, that was really the argument, or they're going to believe in, crystal healing if you tell them that quantum mechanics is strange. And as a matter of fact, when Bruce first proposed teaching the course, another faculty member said that what you are doing is like giving a loaded gun to a child. And Bruce says, well, I'll teach him gun safety. And, the gun safety is the scientific method. What we're saying is that the weirdness of quantum mechanics is demonstrable with the scientific method. So even if you're saying that the scientific method is the only criteria for truth, and I don't buy that, it's just the accepted one in science. If you say something can't have a scientific explanation, you're not saying that it's not good. It's not science good, anything else bad. It's just, I think it's legitimate to say, well, it's not science, but that's okay. But what people are afraid of is, again, that, if you say scientists have demonstrated that there's really weird things about quantum mechanics, people will then believe in faith healers. I think at least some people are smarter than that.
Yeah, well, that's the fear that I see, genuine fear, even if they don't speak it. I see it in the eyes of sometimes when I talk to people who are particularly subscribing to a materialist paradigm. As soon as you deviate from the classical physics path, you get into the quantum realm, and then, as you mentioned earlier, that can be interpreted as sort of mysticism. And then from then, you get religious, spiritual, before you know it, God is being invoked, and that's certainly a lot of the popular science books in this area have got that sort of stuff in the title. And then once that happens, and I've made this point before, the door is open for suicide bombers and the aforementioned right-wing preachers in the US, and it's all these other lunatics come charging in going, see, we told you there is a creator. And that's kind of almost like a a floodgate that a lot of people don't want to even have a chink of it open.
Oh yeah, I mean, and some people are very blunt about that. When I gave a talk I don't even remember, it may have been even before we wrote the book. I gave a talk on this topic at the university, and somebody in the audience, one of the senior faculty members, got up and says, "You're trying to take us back to the Middle Ages," So yeah, I think that is a real fear. I mean, as most people who've read our book have said, we try extremely hard to walk a fine line, and stay off what the people we're talking about consider a slippery slope. We try to talk right on the edge of it, and I share that feeling. I mean, we have, scientists have hard won some real facts about the universe, and I think a lot of damage is done even today by people who, don't accept, the scientific paradigm in certain areas where it works very well, in the areas of, quote, alternative and complementary medicine. And there's some good stuff there, but, there's also a lot of nonsense there too. And part of the problem is, you're right, there's a certain arrogance. It's just like a beef I always have with doctors. I know that doctors know things, but I also know there's things that doctors don't know. And I just wish they'd be a little more straightforward when they don't know what's going on. And some doctors are good that way, but an awful lot of doctors feel like they have to, come across as all-knowing. And that turns people off because nobody is all-knowing.
Well, just last time I was at the doctor's many years ago, I'm pleased to say, I sat down and he basically said, "Oh, here, I've got this problem, this muscular problem, blah, blah, blah." And I said, "I looked on the internet and he just, he just rolled his eyes. You could see that it was borderline disgust that I even bothered to look this up."
Well, but the problem is there's a certain truth to that because there's so much crap on the internet. I mean, without some kind of basis for judging, how do you know what's true? I know people who scare themselves to death all the time by looking on the internet whenever they have a twinge in their little finger, and they, you can find that it's a symptom of some, debilitating disease, and because they don't have any basis for it. So unfortunately, the doctor has some grounds for rolling his eyes. Now, he doesn't know you. He doesn't know that you may have the judgment to be able to tell nonsense from perhaps useful information. But I'm sure he has clients who can't.
Oh, absolutely. I mean, it's sort of, I totally agree. And that's got many overlaps with what we're talking about.
Right.
You said in the book anyway, the differences of perspective. But just to change tack, again, one of the things that I took away from my early readings about quantum physics was this idea, of entanglement, which you could read again from a lay point of view as everything's connected at certain points, space and time.
That's not a bad way of summarizing it.
And there's a little line again in the book which I really liked, which was something at the edge of the galaxy can instantaneously affect the edge of your garden, But
right.
And that has certain implications, I think, for actually how we should live. And again, I'm not trying to get metaphysical or go all tree hugging on you, but I think that if we ponder again on the meaning, as opposed to sort of necessarily a hard scientific fact, but if we think about the potential implications, we see that the interconnectedness on the quantum level can, in a way, be seen. Well, you look at our ecosystem, for example, and it's very clear that we're all interconnected, the natural world, we're a part of it, and that cooperation, not competition, really, is how we should live. And again, sort of somewhat beyond the scope of your book, but that's something meaningful that I would take away. And it might be purely subjective, but I don't know, it feels right.
I have to both agree and disagree with you if I can.
Oh, absolutely.
I think personally that rock bottom values cannot be derived from facts. I think now, there's an argument there, but what I think is you start with that value and then you take what we say as an example of it. And that's perfectly legit because I share that value with you, and many people do. But what I like to say, because part of me is a hardcore skeptic, what I like to say is, well, if people say, well, everything is one and therefore you should be kind to your neighbor, I say, well, yeah, but what if that one is masochistic? I'm sorry. But I guess what I'm saying, the value that, because to me, there's a logical gap there, and a purely logical gap. Everything is interconnected, yes. And then you say, therefore we should, and I don't think you can derive that. I think you start with that value, which we have developed at least, although, we honor it in the breach rather than the observance of, thou shalt not kill. We believe that sometimes, and we don't believe that when it's convenient not to believe that. We start with that value, and from that we can extend it to, taking care of the universe, because we are all interconnected with it. But we don't do a very good job of it, do we, collectively, taking care of our planet?
No, we don't. And I can accept the points you just made. That yes, I guess some of us observe interconnectedness in the macro world around us in living systems, and then we kind of read about quantum mechanics and kind of go, well, that's kind of neat, It's...
Well, I think I think it is. I think it really is. I think and to me, there's something deeply satisfying, about that. But of course, that's, in some sense, the moral idea of it is not a new one. People have always perceived our oneness with nature. It's fairly obvious that we are creatures of nature and we depend upon it, and we're certainly part of this world. We have the ability, though, both good and bad, of imagining we stand off from it. That's the objective thing. We can imagine we're not part of it. I think that's an illusion, but it's a powerful illusion. I won't say necessarily useful, because it's both useful and destructive. But I think it's a very powerful illusion we have, that we can stand off from nature.
Another quick 90-degree turn. I was doing physics at high school during the late 1980s. Mm-hmm. And I didn't do, years and years of it. I did just, I suppose in total it would have been about 3 years.
Mm-hmm. Well, that's far more than most American students.
Yes, well, no mention that I can recall. I really think I would have remembered this. No mention of quantum physics. I had no idea what that was at that time. I'd heard the word quantum, but didn't know what it referred to. Just knew it was science. And that seems strange to me that at that late on, and I feel that it's still not being integrated into science teaching. And obviously you've got to update a hell of a lot of textbooks, and there are, investments in there with careers, and certainly the pressures in the school system sometimes have got nothing to do with delivering the best curriculum. It's
we do a lousy job of it. I agree completely. Matter of fact, God, when I was an undergraduate majoring in physics, and we did not talk about quantum until my junior year. I had 2 solid years of college physics with not a mention of quantum. So, and now today, it's a little better. Mostly you don't get it until your sophomore year. Okay. So, academics in general are very traditional in the way they do things. They may think far out things, but they act very traditionally. Now, there's been some try to change it. I have a book, or I think I gave it to somebody. No, I gave it away. But at Colgate University, some physicists tried to turn it around and introduce quantum physics in the very first year to get people excited about physics, and then go back and pick up, some of the later, some of the stuff you need to become a physicist, some of the tools you need that are really easier to learn in classical physics, but we still almost teach physics in a historical sense. We start with Newton, then we go to electricity and magnet, because we start with classical mechanics because that came first. Then we go to electricity and magnetism and theory of heat because that came next, and then we do quantum mechanics because that came after that. But so your experience, unfortunately, is not at all unique.
In the book, towards the end, you get into a section where you're talking about things on a cosmic level, or certainly, galactic anyway.
Sure.
Looking at black holes, dark energy, and the Big Bang, and of course, that's a whole other area. It's fascinating to contemplate the quantum mechanical nature of things on that scale, and what quantum mechanics might be able to tell us about particularly things of that nature that again are still theoretical, but they're being posited to fit with observables or fill in some gaps in our understanding.
Well, in some ways we put that in because we felt we had to make it complete. It's not the area of expertise of either Bruce or I, so it's probably almost even it was a little rushed. But yeah, certainly, I mean, there are, the big conundrum in theoretical physics is still trying to put quantum mechanics and general relativity together, which is what you need to do if you're going to talk about black holes. Or the beginning of the universe, and that's still very, very difficult, and nobody's done it in a satisfactory way, though. So it's fascinating stuff, but I think in some ways our point in the book is try to be, the mystery is right in front of us, because quantum mechanics, works right now. Everything we put in front of us is built out of atoms, which obey the laws of quantum mechanics, and presumably those laws go all the way up. So I think almost the point of our book is that the real mystery is right in front of us. You don't even have to go back to the beginning of the universe or to black holes to see something mysterious. It's right there where we are.
When you were describing earlier the results of experiments that seem to respond to which of two experiments, for example, you decided to do, you then get into the area of sort of creating history in a way. I know you can you put this in a more scientific way. It's sort of a retrocausality. And I interviewed Amit Goswami on here, and he was talking in his book about the idea that something like the Big Bang could have happened in retrospect. But you do deal with that general issue of that, history seemingly, being played from the present backwards.
That was, that kind of idea actually comes from, some fairly respectable physicists, Martin Rees and John Wheeler, both made very similar statements that the universe, I'll quote here from our book, quoting Martin Rees, the universe, in the beginning, there are only probabilities. The universe could only come into existence if someone observed it. It does not matter that the observers turn up several billion years later. The universe exists because we are aware of it. And then there's a picture a few pages later, which shows an eye looking back at the Big Bang. That idea was introduced, maybe a little bit tongue in cheek by, some very eminent people. And of course, it seems totally ridiculous. But on the other hand, we are led to it because of quantum mechanics.
Yeah, so I think the idea that, some of these ideas getting described as quote unquote absurd, you then get down into semantics and saying, well, if something appears to be, you're sort of, as you said, using a scientific method to verify some of this stuff, then people can say it's absurd, but then what does that even mean? It's a part of our language and invention. There it is,
Right. Exactly. Yeah, it's fascinating stuff.
Well, just as we draw things to a close today, Fred, I mean, some of the implications, if you take them even to illogical conclusions and speculative theories, are mind-bending. But I think that you make a point that quantum mechanics is not the whole story. And in one way, it's merely revealing our limited understanding of reality, whatever that is.
Mm-hmm. That's very possible. I think that's a feeling I've had quite often, that in some sense it just shows we're at our edge. But again, the fascinating thing is we never know exactly where the edge is. Whenever anybody says, well, you can't go any further than this. Somebody goes a little bit further. So I'm sure the edge is there, but it's a fuzzy edge.
Yeah, and who knows? Again, the tendency with modern science is to have some profound insight that's a bit of a game changer, and then say, okay, at last, now we've turned the final corner, we're over the final hill, let's just tie it up, and then something else comes along, and it's like, okay, so who knows what lies above and beyond and behind the quantum world? Is that the fundamental nature? There's nothing that necessarily would say that it has to be. We
don't know. At the moment, that seems to be as far as we can go in that particular direction. And whether you can go farther or not, I guess remains to be seen.
Excellent. Well, Fred, the book is widely available. Once again, it's called Quantum Enigma, Physics Encounters Consciousness. Perhaps before we close off, you'd like to share with listeners, I know there's a website devoted to the book, or any other resources that you'd like to share?
I think if people really want to go further, at the back of the book, there's a list of kind of recommended readings. And I think that would be a good place to start. I don't recall whether that list is on the website or not. But, certainly go to the website, quantumenigma.com, get the book. You can get it on Kindle, if that's your thing, and if you want to go further, look at some of the resources at the back of the book.
Excellent. Well, once again, Fred, thank you so much for joining us today on legalizefreedom.com.
Well, thank you very much, Greg. I've enjoyed it.
Well, folks, that's it for another week. As ever, thank you so much for listening. If you enjoy the show, please check out the website. That's legalizefreedom.com, legalize-freedom.com, where you'll find an archive of programs offering alternative views on a wide range of topics, including world affairs, politics and economics, science and technology, religion and spirituality, conspiracy, and alternative history. You can also browse and buy a range of books and DVDs from our guests, and if you're feeling generous, make a donation to help keep the site up and running. Until next time, I'm Greg Moffat, and you've been listening to legalizefreedom.com.